In this video, we're going to do a more involved example of a decreasing annuity in which the payments decrease once per unit of time and arrive m times each unit of time. So I'll step away and let you copy, but I'll just warn you that this time value diagram is rather complex, so if it's not all clear, maybe wait till I talk through it before you write the numbers in. All right, so we have a 5-year annuity. It's going to pay $60 at the end of each quarter for the first year, then $50 at the end of each quarter for the second year, $40 at the end of the third year, then $30 at the end of each quarter the fourth year, followed by finally $20 at the end of each quarter the final year. And we want the present value, and we know our annual effective rate of interest is 8%. All right, so the bottom line numbers on the time value diagram are the end of quarter payments as stated in the problem, 60s, 50s, 40s, 30s, 20s. Now, for a decreasing annuity where the decreases happen once per time unit and the payments are occurring multiple times per time unit, figuring out the X is typically the trickiest part. So what I pick up from the problem is that each year the quarterly payments are dropping by 10. That means in the final year, I'm going to start everything as every quarter's payment as 1 copy of 10. Second to last year, I'm going to have 2 copies of 10, and then 3 copies of 10, 4 copies of 10, 5 copies of 10. So I'm going to build the time value diagram backwards. So this middle line is the decreasing annuity oddball. And once again, because I saw a $10 drop each quarter, I want the final year to be 1 copy of that $10 each quarter, okay? $1, 1 copy of 10, 2 copies of 10, 3 copies of 10, 4, etc., right? Now, with that, there still needs to be a leveler added to this to make it right. So at each stage, the bottom line is 10 more than the middle line. So I have to add a $10 at the end of each quarter level annuity for the entire 5-year plan, all right? So I've got this middle line, this decreaser, in exactly the same format as the previous video had with n times x, n minus 1 times x, n minus 2 times x, etc. And finally 1 times x. Sorry. N times x divided by 4, n minus 1 times x divided by 4, n minus 2 times x divided by 4, followed by x divided by 4, okay? 4 payments per year. All right, so going off to the side, I remind myself of what the present value of a decreasing annuity immediate of this type is, and that was from the last video. And I recall from the last video that X represents the amount of money I receive in the final year. So during this final year on the decreaser, I've received 4 copies of 10, so $40, all right? I also have this level annuity, which will come into play later on, but just for the decreaser, my X is being played by 40. I'm getting payments 4 times a year, and I have 5 years worth, and I have a yearly effective interest rate of 8%. Now the formula tells me I need to know the nominal rate compounded quarterly. So I go do some work for my nominal rate compounded quarterly. 4 quarters of quarterly effective is the same as 1 year of annual effective. I know my annual effective, so I can solve for I4 over 4, and thus for I4, all right? Turns out I will need both the I4 over 4 and the I4, so the quarterly effective and the quarterly nominal. All right, so that's my scratch work. Overall, the present value is going to be the present value of the nice level quarterly annuity plus the present value of the decreasing annuity, all right? So the quarterly level annuity is making $10 payments each quarter. So it's $10 payments. There are 4 times 5, 20 quarters, and my quarterly effective interest rate is the 1.943%. So I have 20 periods, period effective interest rate, $10 each period, and it's immediate. Plus, the decreaser from the previous video, my X is 40, 5 years, annuity immediate for 5 years at 8%, divided by a nominal quarterly interest rate, the 0.07771. So there's the formula I'm eventually coming up with. Punching things into my calculator, I end up with $682.90. But what we're seeing here is 2 videos ago we had an increasing one where it increases once per time unit but payable m times per unit. And there the numbers matched up perfectly with the formula. Here, the numbers don't match up perfectly. We had to separate out a leveler in order to get the decreasing annuity numbers to line up with the formula as it was presented in the previous video. So these can be rather tricky. Now, worst case scenario on exam FM, you're confronted with this problem. There's only 20 payments. You could brute force each and every one of them back with a quarterly effective interest rate and add them all together. Save that problem till the end, and if you got 10 minutes, you can brute force this thing out without ever knowing the formulas. Just drag each individual quarterly payment back however many quarters and then add them all together.